Hello guys, if you like my awesome gaming videos, my programming and web development courses, my editing courses and editing videos, and my tech talks and tech guidance, then you can consider subscribing to my channel and click on this bell icon to stay connected with me all the time. Hello guys, in this video we're going to work with the binary search algorithm, which is very important. Let me show you what does that mean. Suppose we have value 10, 20, 30 and 40. We have to search this 30, and first one, this is the target value we want to find in the search algorithm, and this 10 is actually the index number 0, this 20 is index number 1, and this 30 is index number 2, and this 40 is index number 3 in the array. Okay, we want to find the index number 2 value. So how can we find that? So what we have to do, we need to find the mid. So how can we find the mid index? Is equals to 0 plus the last index, which is 3, divided by 2, and we're gonna find it 1.5. okay, so this is our main value, but 1.5 is not an array index, proper array index, so we have to take 1.5 is equals to approximately 1.0 or 1. Okay, so this is the value that we want. So if we find one index, this is actually the mid value. If we have 4 element, one of 30 or 20, these two value can be mid. But here in the calculation, I have added this 20, which is the index number 1. This is actually one mid value. So we have to calculate mid. So all of the information, if we find the mid is 20, if the value or the targeted value is staying on the greater side of 20, which is 30, and it is staying at index number 2. So we need to increase our mid to 1. So you have to increase mid plus 1, and then we'll find our required value that we want to have, like 30. Okay, so mid plus 1 is equals to 2. Mid is actually 1 index, and go to plus 1, which is index 2, and this is the place where the 30 is there. So 30 is the value that we want, so we just increment mid plus 1. But if the value, this is the value, if we wanted this thing, suppose 10 we want, then our mid is 1, but our required value is -1. So this value is smaller than 20, so we should decrement it. So mid should be -1. So 1 minus 1 is actually 0 index. So this is the value we want. So if it is greater, you just increment the mid. If it is smaller than, if the target value is smaller than mid, you just decrement it. If the target value is greater than the mid, you just increase the mid. Okay, so this is the thing we want. So if we want to implement that, it is very simple. Search.js. So first we have to make our array, which is our number of array, and here we'll take some values like 10, 20, 30 and 50. Okay, suppose here I want to find this 30. This is the algorithm that we make, and 10 is index number 0, 20 is 1, then 2, 3 and 4. Okay, so we wanted to do that, so we have to create a function, and this function we can call it binary underscore search. Okay, function binary search takes the array which we want to loop and the target value. Okay, so this is very important. And now you need to have two more information, which is left index, which is the left index is actually 10. Okay, it is the starting value. Left index is 0 by default, and we need one more index, right index, which is actually the last element of the array. So how can we do this? We have to go to our array dot length -1. Okay, so this is our last element. Array dot length is the last element -1. Okay, so this is the right index. Now we need to find the mid. So how can we find the mid index? We just need to add those two index. Left index is 0, so let me do this. Left index plus we need to add the right index, which is this 50. So first index is 0, then 1, 2, 3, 4. So 0 plus 4 divided by 2, which would be 2. Okay, so 0, 1, 2. So this 30 would be our mid index. Okay, so this is the thing we have to find. So left index plus right index divided by 2, and we have to do this inside math.float. because if we have suppose we don't have 50, then what should be the mid? 0, 1, 2, 3. Then 3 divided by 2 is 1.5. Okay, 1.5. Then we should take the floor value, which is 1, and 1 should be 0, 1. Then 20 would be the mid value. Okay, so that's why you need to take math.floor. So it should be math.floor, and inside that we will calculate it. Also, we need to add a parenthesis here, otherwise there will be some calculation error. We need to add left index plus right index divided by 2 to get the mid index. So this is the algorithm that we have to follow. If the value that we want is smaller than mid, we need to decrement. Okay, so this is a very important thing. Here I'm gonna write our main logic. While left index is smaller or equals to right index, you need to do this for a couple of, you have to do this until this left index is greater than or equals to the right index. So you have to do all of the operations when the left index is smaller than right index. Okay, so basically the left index is smaller than the right index, so this should happen until the left index is smaller than right index. Okay, so till then you have to check, then you have to write if our target value that we want to find, suppose 40 here, and our mid index is 30. If it is bigger than our mid, then we need to increase our mid plus 1. Okay, if it is smaller than our array, we need to go to the mid index. Okay, if the value is smaller, if the target value is smaller than mid index, then we need to go and write left index is equals to mid index. As it is as our target value is smaller than our mid, so we need to go to the left side, and for that we just decrement it. Then our right index, actually this should be right index. Right index should be mid index minus 1. Okay, we need to decrement the right. Else our left index, if the target value, it says if the target value, suppose 40, is greater than the mid, then need to increment from 30 to 40. Okay, then need to increment the left index to mid index plus 1. Just go to mid index plus 1, which will take you to 40, and this is the target value we want. Okay, but if it is smaller, if the target value, suppose 20, is smaller than our mid, then we need to decrement the right. It will go from 30 to 20 and give you the result that you want. Okay, so just decrement the right index, and if the target value is bigger, then you just increment the mid index plus 1. So this is the main logic of binary search tree. One more logic we have, we can do this. If our target value, which the value we want to find, because this is the searching, we have to find some values, that's why it calls binary search. And binary search is because we are dividing the index by 2, and we are making 2 separate arrays. First is we are dividing it by mid, and all the thing is bigger than the mid is the right part, and all the thing that is smaller than the mid is the left part. We're dividing it by 2, as you can see, to find the mid. Okay, and if we find the mid value, if your target value is 30 and this is your mid index, then you just return it. If your target value is equals to array and go to the mid index is actually 0, 1, 2. Okay, and in the 2 we have the 30 value. If we want this value, if our target value is equals to array.mid, then you just need to return that. You just have to return mid index. Okay, very simple. The left index cannot be bigger than the right index, because right index is always bigger. Okay, this is the last index in the array, and the left index is always smaller. So it will go from this index, then this index, then this index, and this index, and this index. Up to this it can go, but it cannot go beyond this. So that's why we have to do this until this is smaller. So that's why we have the for loop, or this. That's why we need to use this while loop. Otherwise, if everything is false, just return -1. It says that you don't find any information. So now we have to just write it. Const result is equals to, as it returns something, we have to use result is equals to binary search, and here you have to pass your array. As you can see in the function, we need to have the number of array. This is the thing we need to pass, and which value we want to find. Suppose we want to find 40. Just copy this, paste it here, and console.log result. Let's check it out. So node search. So I think there is some error, so let me just cut this thing and put it here. Okay, so In the beginning you should have only the left index and the right index, which is array.length -1, which is the last element. And in the while loop you have to write mid index, because here you need to find the mid so that we can calculate all the thing. Okay, you can return the value. We can go to our array, and this array is this array, and you need to return the mid index value, and it will return the value of, suppose array give me the value on the index 3. This is the value we want. So let me check it. Okay, as you can see, we got the value of 40. So this is the thing we have wanted. Okay, if you want the value, you can return this, or you can just return mid index. That will give you just the index value. So let me check it. As you can see, so the binary search tree is very simple and easy to implement. Just you need to use the left index, right index, and just until the left index is smaller than the right, just continue to find whatever you I have already told you. If the target is smaller than mid, then you need to decrement the mid and put the value into the right index. And if it is bigger, then you need to just increment the mid +1 and put the value in the left index. Okay, return that. So it works perfectly without any issues. So I hope you understand the binary search tree, which is very simple. So the complexity analysis should be for searching. For BST, it should be, for searching, it should be O of log n. So the complexity for the binary search tree should be O of log n. Should be very simple, because you have to divide the whole array divided by 2. So that's why it is smaller. It is much better than linear search tree. So it is much better than linear search, because you are not just iterating through every single element in the array. You are just finding the required target value from this array by dividing them by 2 halves. Okay, and just comparing them with the mid. So this is very simple, and this is much faster. So log n is much faster than O of n time complexity. Okay, so this is the time complexity you have to understand. This is the average case and the best case, and the worst case is a little bit of tricky. Worst case would be order of n square. So in the best case, so this is actually the average case. The log n is actually the average case of binary search tree. But when you want to have the best case is actually when you want to get the value, suppose 30, and it is the mid index. Okay, and when the target value, the value want to find here, as you can see, the target value is equals to the array of mid index 30. Then it is very simple. You just divide it by 2 and get this value. Then it should be O of 1. Okay, you just get it by 1 iteration in the beginning. In the beginning you get that value, but if it is not, then you need to iterate through and check if it is smaller or greater than mid. You have to check all of those things. So that's why you have to have a log n. So basically the complexity is very simple to understand. BST best case. As you can see, the best case for the BST is order of 1. Okay, so as you can see, it says the best case time complexity would be O of 1 with the central index would be directly match the desired value. So if you just Google a little bit, you understand very simply. When you just get the mid index value, and this is your targeted value, this is very simple. You just get it by 1 chance. This should be constant complexity order of 1. But if it is not like that, then you have to use this best case or worst case or average case. You have to use this log n, which is much faster than order of n. So that's why the binary search tree is much faster than linear search. Okay, so that is important. So I hope you understand a lot of amazing concept in this video and understand how the binary search work, and now you can implement a lot of things in a lot of places, how all those algorithm work. As you know, I have made a video on Q data structures and get all the values like NQ, DQ, and all the functionality and all the logics and algorithms that I have used on that. And also I have worked with the stack data structure as well to implement the push, pop, peek, empty, size, all of those things inside this stack. Okay, with the OP knowledge.